I'd like to show you something that's been kind of challenging in lesson 1.1, where we're comparing some fractions and some decimals and even sometimes some whole numbers. So this is a recent warm-up that we worked on in class. If you notice, students should be looking at these two fractions and noticing that denominators don't match. If that's the case, we really want to find a common denominator for both 11 and 9. One way to do this would be to count multiples, counting by 11, 22, 33, 44, 55, 66, 77, 88, 99. That's probably far enough to go. And actually, if I look at these numbers, I notice that 9 times something would actually get me 99. I think that 99 could be really helpful. So if I were to count by 9s in the same way, I could keep on going until I get to 99. I think it would work. Let's see here, 90 and 99. 99 happens on both lists. So another way to do this would be to use your multiplication chart to go across both the 11s and the 9s row until you find a common denominator of 99. So using this idea, we're going to turn both of our fractions into 99ths. So I'm going to take this first fraction and I'm going to write 3/11ths equals some number of 99ths. And on the other side, I'm going to show you 8/9 is the same as some number of 99ths. Well, there's got to be a way to get there. From 11ths to 99ths, I'm multiplying. I multiplied by 9. If you do that to the denominator, you use the same rule with the numerator, and 3 times 9 is 27. On this side, I used a different rule to go from 9 to 99. I used 9 times 11. Well, then, using the same rule in the numerator, 8 times 11 is 88. I'm now able to compare these. I have 27 99ths compared to 88 99ths. And looking at the denominators, they match. They're the same size pieces. So who has more parts, the 27 or the 88? Well, the answer would be the 88. So the only inequality symbol that will work here is the less than symbol. 27 99ths is less than 88 99ths. As long as I'm organized about my work, this inequality symbol will move straight up into my answer. As long as I kept this 3/11ths on the left side of my work and this 8/9 towards the right, this inequality symbol will still be facing the right way. If you take a look at this next one, I have a fraction and a decimal. This one's a little bit trickier maybe. There are a couple things I could think about. Well, there might be a way to turn this decimal into a fraction. Lots of students wrongly think that it is 3/6. Not true. In fact, we need to think about what place value it lands in. So I see 36, but they go to the hundredths place, tenths, hundredths. So now I have 3/6 compared to 36 hundredths. Problem, I still can't compare. These don't have the same size parts or denominators. So we're going to try again. We need a common denominator. 600 is awfully big, but I know it will work. So this is one possibility. There are other ways that students may find. As long as we have a common denominator and we're using the same rule along the way, we should be okay. So how did I go from 6 to 600ths? Well, I multiplied by 100. And if I do it to the denominator, I use the same rule with the numerator, and I will have 300 600ths here from 3/6. So these really are equivalent heading down this way. Next up, this 36 hundredths. I do need to change it. I need to get to 600ths. So I can multiply the top and the bottom by 6. So 6 times 100 is my 600. And 6 times 30 is 180 plus 6 times 6, which is 36. I think we'll get an answer 216 here. My denominators match. We have the same size pieces. But who has more parts? Well, 300 or 216? The answer is 300. 300 600ths is greater than 216 600ths. I can move this inequality symbol into my original problem. This last one is kind of challenging because there are two decimals and they seem to have a lot of the same numbers. They both share this 12 in the whole number. So this part looks the same. But as I move to the next place value, I notice that they look a little bit different. In fact, this one lands in the tenths place while this one ends in the hundredths. To make them end in the same place value, I could put a 0 behind that first decimal. This really starts to look like, you guessed it, money. So would $12.40 be greater than or less than $12.09? The answer is greater than. Let's pretend you didn't notice that. Another way that you could work out this problem would be to show a mixed number. I could rewrite both of these in mixed number format. The 12 is the whole number, and now I have to decide how to write the fraction. Well, this 4 was in the tenths place, and this 9 was in the hundredths place. Oh, I still can't compare. Tenths and hundredths aren't the same size pieces, so you really are going to have to change this denominator somehow to match. Well, hopefully you're noticing I could really multiply the top and the bottom by 10 and see what happens. I'm trying to get the same denominator, and I know 10 times 10 is 100, so I think this is going to work. 4 times 10 is actually 40, and this other fraction gets to stay the way it was. Well, the 12 is the same, doesn't really determine an answer. The denominator is the same, doesn't really help me out right now. What's going to tell me who is greater or less than is my numerators. Is 40 greater than or less than 9? Well, the answer is it's greater than, meaning this whole quantity over here must be greater than the whole quantity on this side. If that's true, this inequality symbol will move straight up into my original problem. Again, we've been working on comparing fractions with decimals, and also decimals to decimals, and even some whole numbers mixed in here. We will be quizzing on this soon, so this is just kind of a friendly reminder on some steps that you might want to practice at home.